Hey everybody, Mr. Covey here, and today I just want to talk about finding zeros of a polynomial. So you guys actually learned this before break, but it's one of the harder things with polynomials, and it's one of the more important things, which is why I just wanted to make a video going over it again, making sure we had it down perfectly, because it is a little tricky. So just a reminder, there's a couple other words we use that also mean zeros, and those are x-intercepts or roots of a polynomial. Those all basically mean the same thing. Now, a little bit of a kind of nuanced difference has to do with whether or not to include ones with i's, but I don't want to really get into that. So even if your roots or x-intercepts or zeros have i's in them, that's okay. We're going to call those all the same thing. Okay. So as a reminder, the general approach for finding a zero or an x-intercept or a root is to make y equal to 0. And always remember that's kind of flip-flop. So like, how do you find x-intercepts? You make y 0. How do you find y-intercepts? You make x 0. So it's kind of flip-flop. So in all of these problems, how are we going to find the zeros? We're going to make y 0. Here are functions written in function notation. Remember that this guy's our y. So we're going to make that 0, and we're going to solve this equation. Now, this is best case scenario. Is an equation that looks like this because it's all factored for us. Remember, factoring is your friend. Factored form is your friend. That's what you want it to look like. Okay, so it's all factored for us. We're going to rely on the zero product property to set each individual factor equal to 0. Okay, so we're setting each factor equal to 0 to get our zeros, our x-intercepts, our roots. Okay, easy to solve. X minus 1 equals 0. X equals 1 is one of our zeros. X plus 1 equals 0. X equals negative 1 is one of our zeros. X squared plus 5 equals 0. Let's be careful here. X squared equals negative 5. Square root both sides. X equals the square root of negative 5. Don't forget the plus or minus. When we have a square root of a negative, we need to pop out an I. It should be plus or minus square root of 5 I. Okay. 1, negative 1, positive square root of 5i, and negative square root of 5i are the 4 zeros of this polynomial. Okay? And I think you guys are good on ones that look like that. I just want to kind of go through the different scenarios. So for this one, you immediately notice there's no parentheses. It's not factored. We are still finding zeros by solving this equation. But since it's not factored, we should try and factor it. We only have 2 factoring strategies for stuff that has cubed in it. First, we should check for a GCF, but like there's no number or something I can take out of all those. And next, I should look and see that there's 4 terms. 1, 2, 3, 4. So I should try some good old-fashioned grouping. Okay. So, excuse me, remember with grouping, you're looking at this first group, and you're taking a greatest common factor out of those. You're looking at the second group, and you're taking a greatest common factor out. Little reminder here. These don't really have anything in common. There is no greatest common factor. The greatest common factor would just be 1. But since this first one's negative, it's going to be helpful to take out a negative 1. You're like, all right, how do you take a negative 1 out of positive 4? Well, you're left with negative 4. The reason we want to do that, of course, is now that these guys match up, and I know my grouping is working. Okay, so now that I've grouped that, again, I want you to think about it as solving this equation. That leads to this factoring. So that grouping helps me get it to be factored. And once it's factored, we do the same thing we did in the problem above. We set each factor equal to 0. Well, if x minus 4 is 0, then x equals 4. And if x squared minus 1 equals 0, then x squared equals 1, x equals plus or minus 1, positive 1 or negative 1. Okay. Moving forward. Okay, I think you guys are good with those two strategies. 3 is where things get a little trickier. So I'm going to save you the time, and I'm going to tell you I looked at it, kind of looked like number 2. I tried grouping, didn't work out. If grouping doesn't work out, you don't have any other strategy. This is when we need to rely on our calculator. Okay, so again, we're trying to solve this equation. We're trying to find zeros. We're trying to find x-intercepts. Those are all the same thing. So I'm going to grab my calculator, and I'm going to type this guy into my calculator. Okay, grab your calculator. Type that function in. And then we're going to go to the table. Okay, so quick, I think you guys got this, but again, I just want to remind you about this because it's important. So we're going to grab our calculator. Give me a second here. Sorry, I lost my calculator there for a minute. I had to find it in my backpack. Anyway, so I typed my function into my y equals. So I hit y equals, typed in my polynomial, and now I'm going to go to the table. Okay, remember the table is where to go, not the graph, because the graph's kind of hard to tell. What I'm trying to find is x-intercepts. And remember what I said earlier here. X-intercepts are when y is 0. So you're looking for spots where y is 0. Okay, so let's go back to our table. I'm trying to find out spots where y is 0. Give me a second here. Okay, so I'm going to start searching around. Boom, I found one, -2. Okay, now what I'm going to do here is I'm going to say, hey, I just found one of my zeros, one of my x-intercepts. I know that x equals -2 is one of my answers. What I'm going to do with that is I'm going to use this idea that if I know a factor, dividing by that factor will tell me other factors. Okay, so x minus 2 is an x-intercept. X plus 2 must have been one of the factors. And so I'm going to divide this polynomial by x plus 2 to get something similar, or excuse me, simpler to help me find my other factors. Okay, if I'm dividing by x plus 2 with synthetic division, I use a -2 there. I toss down my coefficients, and I do my synthetic division. Okay. Because my calculator told me it was an x-intercept, I get a remainder of 0, and I'm like, good, I better have. Okay. These 3 numbers are my coefficients. I divided a cubic, 3rd degree, by a 1st degree. 3 minus 1, that's 2. So I should get a squared polynomial left. I should get a quadratic left. And here's what I got. And I'm still setting this equal to 0. And now I'm solving this equation. Okay, this is a normal quadratic. You guys know how to solve this. Does it factor? Well, what multiplies to 17 adds to 8? It does not factor. So I'm going to do quadratic formula. Okay. Be careful about my simplifying here. I'm going to do -8 plus or minus. Type all of this in my calculator. We get -4 all over 2. And again, there's some different ways to simplify here, different steps, but I'm going to do this. I'm going to split it up. Okay, I'm going to split it up into this and this fraction. So I'm going to split it into 2 fractions because I think it's going to make the simplifying easier. Don't have to do this. You can do any mathematically legal way to simplify this. But I'm going to rely on that fact that I know from other math classes that I can split up a fraction like that. -8 divided by 2 is -4. Here, what's the square root of 4? Well, it's 2, but it's got a negative, so I'm going to get an I. So I'm going to have 2i over 2. Well, 2i divided by 2, that's just I. So my answers there are going to be -4 plus 2i and plus I and minus I. Okay, so these are the other 2 root zeros of the function. And remember that I also got -2 from the calculator, so I should list that one out as well. Okay. All right. Flipping it over. I want to do a couple more really quick. For this one, making y 0, trying to solve this equation. It's not factored, but if I look at all these, what do I have here? I got a GCF. I should take out that GCF because that's a little bit of factoring I can do on my own. This makes my life a lot simpler because now this part equal to 0. Well, x equals 0, that's one of my roots. I already have one right here. The thing I'm left with, what's nicer about this than what I started with, is it's squared. And I know how to solve squared equations. Again, I'm going to try and factor this to figure out my other two zeros. It's not going to factor. It multiplies 13 as a negative 4. It doesn't happen. I'm going to use quadratic formula again. I'm going to split it up again. And I'm going to figure out what this is. So what's that going to be? 52. Right here. 4 divided by 2 is 2. Square root of negative 36 is just going to be 6, but with an I. 6i divided by 2 is just 3i. So here are my three different roots, three different zeros. Okay? I want you to note here, we took out a GCF to give us that first one that kind of kick-started the rest of it. In the previous problem, we didn't have a GCF, so instead we used our calculator. Okay, so your calculator is always your last resort. All right. Final note with this one real quick. It was cubed, so I expected to get 3 roots. I didn't say that in the previous ones, but I've hoped that you've noticed that. 3 roots, well, that makes sense because it was cubed to start. 3 roots makes sense it was cubed. 4 roots, oh, that's because it was first degree, second degree, 1 plus 1, but 4th degree. So if you foiled this all out, you would have gotten a 4th degree, which makes sense why we had 4 solutions. So keeping that idea in mind, for this one, I'm going to expect to get 4 roots, 4 solutions. And I'm going to move this stuff out of here. And again, I'm going to say, hey, is it factored? No. Can I take out a GCF? No. Can I do some grouping? No. Okay, well then I'm going to go to my calculator. Okay, so I'm going to type this guy in my calculator and I'm going to grab an x-intercept. You pause right now and go ahead and do that. Okay, I hope you did that. What you might have noticed is you kind of had 2 choices. You had 3, and you also had -3 to choose from. Okay, so let's just keep that in mind. I'm going to pretend like I just saw one of these. I'm going to say I just saw 3, and I'm going to use 3. So I'm going to do my synthetic here real quick. Okay, so I'm going to divide using the 3. My coefficients, be careful. They're 1, 0, because there's no x cubed, -7, 0, because there's no x, and -18. So I'm going to do my synthetic real quick. I got a remainder of 0. Perfect. That's what I wanted. And what I'm left with here is cubic, because it was 4th degree and I divided by a 1st degree. So I have x cubed plus 3x squared plus 2x plus 6 equal to 0. Okay. And now I'm kind of back to square one here. And I want to kind of go through my processes again. So it's cubed. So I should think, can I take a GCF out? No. Can I do grouping? I don't know. Let me try it. Okay. So I'm going to take an x squared out. Excuse me. So I'm going to take an x squared out and be left with x, plus 3. I'm going to take a 2 out. I'm going to be left with x plus 3. Again, since those 2 things you're left with match up, grouping is working here. So I'm going to finish up my grouping. I'm going to set each one of those factors equal to 0. Well, if x squared plus 2 equals 0, x squared equals negative 2, x equals plus or minus the square root of 2I. Hope you guys are getting good at that now in the other chapters. X plus 3 equals 0, x equals negative 3. Cool. And what you'll notice here is, like I anticipated originally, I got 4 x-intercepts. 1, 2, 3, 4. Now, something to keep in mind, you could have done this differently if you'd used negative 3 as your original 1, but at the end of the day, it should have worked out exactly the same way. Okay, you should have still gotten the same 4 zeros. In fact, we kind of just like our algebra confirmed that other x-intercept that we saw from the calculator. Now, we weren't going to get plus or minus square root of 2I from the calculator, but we could have gotten 3 or negative 3. So it kind of confirmed that negative 3 was one from the algebra, and it also told us on the calculator. Okay. I'd like you to do these 2 practice problems. The bottoms are on, excuse me, the bottoms. The answers are on the bottom, upside down. So they're kind of down there, flipped over. Try and do these 2 problems. You'll notice both of these are not factored. So kind of go through your processes. Okay. And that concludes this video.